All right, this is homework number 13, the last one. Practice problems. Let's go ahead and get started. All right, problem number 1, A, rewrite as a logarithmic expression. So, so the base of the exponent is the base of the logarithm. So we know it's going to be log base 4. The answer for this one becomes what we're taking the log of, 1 over 64. And then the exponent becomes the is the answer. So this is -3. So base, answer, exponent. Base, answer, exponent. So logs are base. Base, answer, exponent. So, little joke. All right. B. Log base 6 of 6 is 1. There's a technique that they use in high school. I think it's called a swirl or butterfly. I don't know. But basically, the base to the answer is the exponent. So 6, well, base, answer, base to the, basically, the base to the answer is equal to that. So 6 to the 1 is equal to 6. So it just asks for the exponential equation. So that's what we give. All right. Mouse here. All right. So we did that problem. Number 2, rewrite each equation as requested. So for A, rewrite as an exponential equation. So a couple ways to think about this. Basically, we know that natural log, LN, is the same thing as log base E of 8 is equal to Y. So then we can do the same thing we did in the previous problem. Or we can raise each side, E raised to each side of the problem to kind of get your answer. So this becomes E to the Y is equal to 8. All right, for part B, it says rewrite as a logarithmic equation. Again, you can take the natural log of both sides, and that really is the easiest way to kind of conceptualize what you're doing. So this becomes, if I were to do that, it would be like the natural log of e to the 5th is equal to natural log of x. The natural log of e, they cancel each other out. So I end up with 5 is equal to ln of x, or ln of x is equal to 5. Okay, let's continue on. Pretty easy so far. Evaluate each expression. So the way I kind of think about it is 7 raised to what power is 49? That's 7 squared. All right. Hold on. Make sure I have this right. Set up right here. Okay. And then 3 raised to what power is 1 over 81? Well, we know it's going to be negative because it's on the bottom. And then 3 raised to what power is 81? 4. So 3 to the negative 4 is going to be 1 over 81 because the negative moves the 3, the powers of 3 to the bottom of the fraction. All right. You should have paused this if you need me to. But let's continue on. So graph the function that and give its domain and range using interval notation. All right. So we know you cannot take the log of 0. So if I put 1 in here, it becomes 0. So line 1 is an asymptote. Let's put that. I put that in there just so you can see it. Cool. So the graph is normally it looks like the inverse of an exponential function. All right, but there are a couple different points we need to know. If I plug in 2, I get the log base 3 of 1, which we know is 0. So 3 is my x value. I'm sorry, not 3. I put in 2 for my x value. So 2 is my x value, 0 is my y value. Additionally, log base 3 of 4 minus 1 is log base 3 of 3, which is equal to 1. That gives me 4, 1. So I have those points. I can put those here. 2, 0, 4, 1. In case you're wondering, 10, 2. Right, because 10 minus 1 is 9, and log base 3 of 9 is 2. And then you just sketch it like this. Something like that, roughly. Okay, my domain, that is 0. I'm sorry, not 0, 1. 1 to infinity. My range, negative infinity to positive infinity, all real numbers. Okay, there aren't any domain restrictions. I mean, range restrictions. It just all goes. Okay, so let's continue. Use the property of logarithms to expand. Log of z to the 5th over y. You do it in pieces. Well, I'll write it in pieces, but so that we can understand it. So this is, on the top is add log of z to the 5th. Bottom is subtract log of y. But I have something raised to an exponent. The exponent goes in front. So this becomes 5 log of z minus log of y. Okay. This is an easier version of the next problem that we're going to do, which is problem number 6, but the same principles apply. Plus we're adding on one more. So break it up into pieces. Everything on the top is positive. So the first step would be log of 2 x plus 7 to the 5th minus log of the cube root of x to the 4th. All right. Log of, this is 2 times x plus 7 to the 5th. So that splits up positively. So log of 2 plus log of x plus 7 to the 5th minus log of the cube root of x to the 4th. Okay, the log base 2 is going to stay. We're done with that one. Plus, that 5 goes in front. So 5 log of x plus 7 to the 5th. And then the x to the 4th, the cube root of x to the 4th. I'll write over here. The cube root of x to the 4th is the same thing as x to the 4/3. The exponent goes on top. The index of the root goes on the bottom. So this becomes minus 4/3 log of x. And then we're done. So, oh, wait a minute. That 5 is gone because we moved it up front. So there are no radicals or exponents here, and everything is there. Next, write the expression as a single logarithm. We get any numbers in, we get any coefficients to our logarithms or anything we're multiplying it by, and we move it back to where it belongs, and then we'll put it together. So we end up with log base a of x to the 1/5 plus log base a of z to the 7th minus log base a of w. Now, Everything that's positive goes on in the numerator. Everything that's negative goes in the denominator. So log base A of x to the 1/5 times z to the 7th over w. 2 steps. Maybe I should put parentheses around these, but same means the same thing. We're zooming through these pretty good. Problem number 8. Let's continue. Okay, we want to evaluate these logarithms. Okay, we do the same thing as far as putting these things together. So first step, we're going to move the 2 to the 4. So this ends up being log base 3 of 4 squared minus log base 3 of 48, which is log base 3 of 16 minus log base 3 of 48. Put them together. Positive, positive, negative. This becomes log base 3 of 16 over 48, which is log base 3 of, this reduces to 1/3. Now log base 3 of 1/3 is -1. All right, there are extra steps in here to explain what's happening. All right, part B, these are logs and they're added so we can put them together. So this becomes not log. So this becomes natural log of e³ times e to the 7th, which is natural log of e to the 10th. Natural log and e cancel each other, so I just end up with 10. Again, pretty easy problem. Or pretty direct problem. Let's not say it's easy, but it's pretty straightforward. It's imperative to know the properties. Knowing the properties make these, in practice, it makes these easy. Question number 9, solve for x. Use our algebra, and then we'll use a logarithmic property. So -8 is equal to, plus. -8 plus log base 5 of x plus 4 is equal to -6. Add 8 to both sides. Ooh, computer's kind of freezing a little bit. Log base 5 of x plus 4 is equal to -6 plus 8 is +2. All right, we rewrite this exponentially. So 5 squared is equal to x plus 4. Or 25 is equal to x plus 4. Subtract 4. And 21 is equal to x. We only use the property of logarithms like right here. Like from this step to this step. That was it. The rest of it was algebra. Okay. Next, we'll need a calculator for this problem. We know that because it says don't round. So, but we do algebra up until we get to the point we don't need it. But we use algebra until we need the calculator. We don't use the calculator before we need it. So 5 is equal to 3 natural log of x equal to 7. That's supposed to be a plus. But no, I want to make everything equal today. Subtract 5 from both sides. And I get 3 natural log x is equal to 2. Divide both by 3. Natural log of x is equal to 2/3. Use our exponential property, and we end up with, or change it to exponential form, and we get e to the 2/3 is equal to x, which is equal to, so now when we put it in our calculator, wait a minute, clear. Now when we put it in our calculator, we're only doing one step. and I get 1.94. Round to the nearest hundredth. 95. All right. Again, pretty straightforward. Okay, this next problem uses a little more algebra. So we move our logarithms all to one side. So let me rewrite the problem and do it like that. Log of x plus 8 is equal to 2 minus log base 2. Put your bases there, even though most of the time you won't need them. X plus 5. Add this to both sides. Plus log base 2 plus 5. And end up with log base 2. I'll do the intermediate step, even though I don't think it's necessary. X plus log base 2 of x plus 5 is equal to 2. Okay, adding two logs with the same base, you can multiply them together. So log base 2 of x squared plus 13x plus 40 is equal to 2. Change to exponential, and I end up with x squared plus 13x plus 40 is equal to 4. Subtract 4 from both sides, because now we're just dealing with a quadratic equation. X squared plus 13x plus 36 is equal to 0. This becomes x plus 9. Scroll that up. X plus 9 times x plus 4 is equal to 0. So we have x is equal to -9 and -4. But when we look at these answers, we have to look at it. If I plug in -9 into this log or this log, I'm taking the log of a negative number. I'm not allowed to do that. X. If I put -4 into these, then I'm taking the log of numbers greater than 0. I can do that. But the answer is x is equal to -4. This problem had a few more steps, but it brought back your algebra 1 and algebra 2 type stuff, or your college algebra type stuff. Okay, let's continue. Almost there. Solve for x. Okay. X log of x minus 2 minus log of 12 is equal to log of 16. We can combine the left side and we end up with log of x minus 2. I don't know why this thing is so sensitive today. X minus 2 over 12 is equal to log of 16. If I'm taking the log of two sides and they're equal to each other, I can disregard the log. So that's a property. If log of A is equal to log of B, then A is equal to B. All right, so that means that x minus 2 over 12 is equal to 16. Multiply 12 by 16, and you get a big number. You get x minus 2 is equal to 192. Add 2. That means that x is equal to 194. All right. For this problem, we're going to use a similar property. Okay. When you look at it, you see that 27 and 81, they're not powers of each other, but both of these are powers of 3. Okay, so this is, I'll do it, 27 to the x minus 3 is equal to 81. So this is 3 cubed to the x minus 3 is equal to 3 to the 4th. Distribute that 3. You get 3 to the 3x minus 9 is equal to 3 to the 4th. All right, if the bases are the same and they're equal to each other, then that means the exponents are equal to each other. So you can disregard them. 3x minus 9 is equal to 4 plus 9. 3x is equal to 13 divided by 3. And x is equal to 13 over 3, which it is. All right. For number 14, we are solving for y. Okay, so this is what we'll do is we'll take the natural log of both sides. So e to the y plus 2 is equal to 5. So natural log of e to the y plus 2 is equal to the natural log of 5. The natural log and the e cancel each other out. So y plus 2 is equal to natural log of 5. Subtract 2 from both sides. You get y is equal to negative 2 plus natural log of 5. Hold on, round it. Whoops. Is equal to negative 2 plus, where we at? Natural log of 5. And end it with negative 0.39. All right, I put this negative 2 plus the natural log because if you put minus 2, you don't want to accidentally think it's the natural log of 5 minus 2 in parentheses, as opposed to natural log of 5, then minus 2. Okay. All right, number 8, solve for x. We are going to need a little bit of space. Yep, we're going to need space for this one. Not every homework has that one problem that you have to do a little bit extra with. This is that problem. So we're going to do, we can do base 10 or base e. It doesn't matter. So I'll do base 10 just because it's what I'm used to working with. So 8 to the negative x plus 3 is equal to 11 to the negative 2x. So log of 8 to the negative x plus 3 is equal to log of 11 to the negative 2x. Move your exponents. So I get negative x plus 3 log of 8 is equal to negative 2x log of 11. Distribution, negative x log of 8 plus 3 log of 8 is equal to negative 2x log of 11. All right, I'm going to add x log 8 to both sides because I want my x terms on the same side. Plus x log of 8. I guess I can go up here now. So I end up with 3 log of 8 is equal to negative 2x log of 11 plus x log of 8. Factor out the GCF of these two numbers is x. So 3 log of 8 is equal to x times negative 2 log 11 plus log of 8. And then I'm going to divide both sides by -2 log 11 plus log of 8. And I can do that because it's all in parentheses. -2 log 11 plus log of 8. Cancel, cancel. So x is equal to 3 log of 8 over -2 log 11 plus log of 8. Boom. I know that y'all don't, I know you may not feel this was fun. I enjoyed that. I thought that was pretty cool. Algebra and using you use a logarithmic property to move the exponents in front. But after that, this is all algebra. This is all algebra. Okay, if you have any questions with this, definitely feel free to ask. All right, number 16, the number of milligrams D of H of a certain drug that is in a patient's bloodstream 8 hours after the drug is injected is given by the following function. D of H is equal to 15 e to the negative 0.5 H. When the number of milligrams reaches 7, the drug is to be injected again. How much time is needed between the injections? So let's do that. This problem won't be too bad. So 7 is equal to 15 e to the negative 0.5 H. Divide both sides by 15. 7 over 15 is equal to e to the negative 0.5 H. Natural log of both sides. Natural log of 7 over 15 is equal to, natural log cancels e, and I just get negative 0.5 H. And we're going to divide by negative 0.5. So that means that H is equal to natural log of 7 over 15 divided by negative 0.5, which is the same thing as multiplying by -2. But you can now put this in your calculator just like this if you'd like. So natural log of 7 over 15 over negative 0.5. And I end up with round to the nearest 10th is equal to 1.5 hours. All right, as is always, if you have any questions about this, let me know. But we have reached the end.